Since ancient times, the moon, the planets and the sun have attracted the attention of amateur observers and astronomers alike. Only in the space age was it finally possible to approach these celestial bodies and unveil their physical and chemical mysteries. And although we cannot travel very closely to the sun, space missions have taught us a lot about our own star. Since the early 1970s, the European Space Agency ESA also set an emphasis on studying the interaction of the solar wind, a stream of energetic particles emitted by the sun, with the Earth's own magnetosphere. Often in cooperation with NASA, each ESA space mission has been focusing on topical scientific questions. Spectacular findings and basic research have been securing Europe a leading role in this field of astrophysics. Ulysses, launched back in 1990, was the first spacecraft ever to watch the sun at its poles, a region which had never been observed before. Ulysses has given us the full picture about the seasonal changes in the solar wind. And it has proven that the solar wind creates a huge heliosphere around the entire solar system, which is protecting us from cosmic radiation from outside. This heliosphere corresponds to the Earth's own magnetosphere that is shielding us from the harmful impact of the solar wind. Five years after Ulysses, SOHO was placed right into the particle stream of the solar wind that continuously blows towards our planet. SOHO was the first to look deep under the sun's surface and detected that the sun is a dynamic star, continuously changing its magnetism and behavior. The SOHO was launched when the sun was at its activity minimum. Scientists have known for a long time that the solar activity follows an 11-year cycle, which is marked by the number of sunspots on its surface. The maximum of the current solar cycle was reached in 2000-2001. The sunspots correspond to violent eruptions, each ejecting millions of tons of matter in the form of highly energetic particles into space. During 6 years in space, SOHO has observed half a solar cycle, and its expected lifetime in orbit will permit it to complete the entire cycle in 2005-2006. SOHO also observed interesting phenomena like comets falling into the sun, in total more than 100. For scientists, these fascinating images mark a giant step forward in understanding not only the sun, but also the interactions of the Earth with our neighbor star, which at times can be dangerous and even destructive. What we can observe as a beautiful aurora in the polar skies is a phenomenon created by highly energetic particles that can also paralyze satellites, power stations, and electronics on Earth. To investigate this violent impact of the sun, a fleet of 4 satellites called Cluster was launched in summer 2000. This ESA mission continuously measures our planet's magnetic shield and records its changes caused by the irregular solar eruptions. Now, with SOHO and Cluster, scientists can start to forecast the effect of the solar wind on Earth. The next generation Solar Orbiter is scheduled to fly in 2011. Solar Orbiter will study the sun from very close by and deliver data on the processes in its atmosphere. It will map the sun's surface to an accuracy 500 times higher than we know today. In the next years, ESA missions will travel to many different places in the solar system. ESA's Rosetta mission will be launched in 2003 and accompany a comet for 2 years, studying it in all its properties. Also in 2003, ESA's Mars Express will search for a hidden water deep under the surface of the red planet. Already since 1997, NASA's Cassini probe is on its way to Saturn, carrying ESA's Huygens lander to descend on Titan, one of Saturn's intriguing moons. Also, the Moon, our closest neighbor, will have a first European visit as early as 2004. The orbiter will be packed with the most advanced lightweight instruments and equipped with electric solar propulsion the most efficient way to travel through our solar system. The Smart 1 mission to the Moon will be the first orbiter traveling through space using only sunlight as a source of energy.